All right, good morning, guys. Go ahead and think about this do now. You do not need to write it down, just think about it. Okay, so difference between a transverse wave and a longitudinal wave. So the transverse, remember, we can do the hand motion like this, and then the longitudinal goes like that. So the transverse wave is going up and down in the direction of the wave, whereas a longitudinal wave is just going right along that wave. The difference between absorption, reflection, and transmission. Carabelle explained one of these really well yesterday in class. So absorption, remember absorption is going right into the object and is not coming back at us. So if we think about light, again, we can think about a plant. The light that is absorbed is all the colors that are not green, whereas the light that's reflected is the green. And then nothing would be transmitted through this, right? Transmission of light is just happening through clear surfaces or somewhat clear surfaces. All right, go ahead and write this down. TE1, properties of matter. So this is a new unit. We're starting technology and engineering. And we're just starting off by talking about properties of matter and materials that you might work with in engineering. First vocabulary word is properties. So a property is a characteristic of a substance. You don't need to write these down. Actually, we're just going to go in depth on each of them, so don't worry about writing down this list. The different types of properties are flexibility, ductility, hardness, thermal conductivity, electrical conductivity, and melting point. And we'll talk about each one of those. So the first one is flexibility. You might have heard people described as flexible if they can stretch really well. A lot of dancers are flexible. So that's talking about being able to bend without breaking. So we can look at an example. This notebook has pretty high flexibility. I can bend it all the way without it breaking. And whereas a pen would not be flexible, right? If I were to actually try and break this, it would break instead of just bending. All right, the second one is ductility. So this is almost always referring to metals. It's about how well it's able to be stretched or melted or pounded out into a thin material without losing its this says toughness, without losing its hardness, its strength. So examples of this, you can think of any jewelry basically. A lot of jewelry is silver. If you jewelers often use a hammer to make jewelry much flatter or skinnier, and they can do that without the silver losing any of its hardness. All right, next is hardness. So this one's pretty self-explanatory, right? Something that is hard has a lot of hardness. Something that is soft does not have a lot of hardness. So it's about how solid, firm, or rigid it is. It's not easily broken, bent, or pierced. This is a picture of a diamond. This is one of the hardest materials out there. A diamond is solidified carbon, and it's super, super hard, which means it's used to test the hardness of a lot of other materials. So back to the notebook example. This is not very hard, right? We know that just from looking at it and how it's able to bend. And also, if I were to write on this really hard with my pen, the pen would go right through it. So that means it's not very hard. Actually, another example would be this terracotta pot. This is pretty hard, but if I were to use a rock or a diamond to scratch at this, it would scratch. So that doesn't have as much hardness as, for example, a diamond or a rock. All right, thermal conductivity. This is how well something allows heat to travel through. So if you have ever helped your family cook and you've used an oven, then you have probably had to take out the pan from the oven using hot mitts, right? Or hot pads, whatever you call them. So the reason that you have to do that is because if you touch the metal pan directly, you can probably predict that it would burn you. It would burn you because it has really high thermal conductivity. So it's going to transfer the heat right from the pan into your hand. The cloth that you use to to protect yourself from that hot pan, that has really low thermal conductivity, which is the reason that it's good as a protective material. All right. Electrical conductivity is very often correlated. It's very often the same in materials with high thermal conductivity. They often have high electrical conductivity. So it's basically something that can allow electricity to go through it. This is generally talking about metals. They conduct electricity well. All right, and the last one is melting point. So this is the temperature at which a given solid will melt. So all of our different elements have different melting points. Probably the only thing that you've ever seen melt is water, and that includes like a popsicle. A popsicle is mostly water, or I don't know. Basically, all the liquids that we use are mostly made of water. So that has a melting point of 32 degrees Celsius or 32 degrees Fahrenheit or 0 degrees Celsius. And that means that that's the temperature at which, if we go higher than that temperature, the ice will start to melt. But water is the only example that we've seen really. But every element has a different melting temperature. I want you to pause the video and think about, does metal have a higher or lower melting point than water? Go ahead and pause and think about that. Okay, so this picture over here is an example of molten metal or melted metal. Metal has a much higher melting point than water. So you can think about, if you hold an ice cube in your hand, it's definitely going to melt. It'll take a little bit of time, but it's definitely going to melt. If you hold metal in your hand, it is not going to melt because it would take a really strong fire to melt that metal. Okay, so we're going to go through a couple of examples. I want you to pause and think about the answer, and then I'll tell you. All right, so this is the more flexible object is the slinky here, obviously, because it's bending. The more ductile object here is the one that's been thinned out. So the one that breaks is not ductile. All right, the harder object, this is a little bit tricky. It kind of depends on what type of wood this is, but let's think about if we had a rock. If we scratch that wood, if it's soft wood, then it would definitely leave a scratch, whereas if we scratch the plate, it might not, depending on whether that's real ceramic and what it's coated with. All right, which one has more thermal conductivity? This one's a little bit tricky. So this is the spoon. Metal always has a really high thermal conductivity. Plastic has a medium thermal conductivity depending on what type of plastic. There's lots of types of plastic, but this is going to be the metal in this case. All right, more electrical conductivity. This is rubber and this is metal. Go ahead and pause and think about that. Metal will always have more electrical conductivity than rubber. All right, this one is a little bit of a trick question. This is ice and this is ice, and even though they are different sizes, they have the exact same melting point. Ice made from water will always melt at the temperature of 32 degrees Fahrenheit. Okay, with that, you can jump into the classwork for today, and I will see you tomorrow at 2 p.m. We're changing that class time because we have some people in 7th grade math, so we'll do Friday at 2 p.m. this week, okay? Hope you guys are doing well.